This video will show you how to visualize a sequence in a sequence diagram. I will illustrate this sequence diagram by using a null sequence. Suppose we are given a null sequence a sub n equal to minus 1 power n plus 1 over n. Limits of a sub n when n approach infinity is 0. That is why an is a null sequence. Which means for every epsilon greater than 0, there is an x such that absolute value of a sub n will be less than epsilon if n greater than x. In other words, a sub n will be less than epsilon and greater than negative epsilon if n greater than x. But then, how do we visualize this? That is, minus 1 power n plus 1 over n is less than epsilon and greater than negative epsilon if n greater than x. What we're trying to find is x. I'm going to show you how to find x when epsilon is equal to 0.1 by using a sequence diagram. What is a sequence diagram? A sequence diagram is a plotting of the sequence an against n. Let's watch a video here. I have a sequence diagram which is a plot of a sub n against n. On this diagram, you'll see two horizontal lines. The red horizontal line represents y equal to 0.1 and the bottom dotted line represents y equal to negative 0.1. And then I'm going to plot my A1, A2, A3, A4, and I'm going to show you the video here. You'll see that the value of a sub n is plotted for different n. For example, n equal to 8, n equal to 9, n equal to 10, n equal to 11, n equal to 12, n equal to 13, n equal to 14, n equal to 15, 16, 17, 18, 19, and 20. And notice that at n equal to 11, you find that the a sub n fall within the two horizontal lines. I have copied the sequence diagram over here so that we can see a clear picture. I have these points, A1 here, A2 is here, A3 is here, A4, A5, A6, A7, A8, A9, A10, and we notice that when we come to A11 and A12 onwards, all the points are inside the yellow band, bounded by two lines, y equal to epsilon, which is equal to 0.1, and y equal to minus epsilon, which is equal to minus 0.1. And in fact, we can verify this by looking at the table that when n equal to 11 onwards, all the absolute value of an will be less than 0.1. Therefore, we can safely say that an will be less than 0.1 and greater than negative 0.1 if n greater than 10. Means n equal 11, 12, 13, 14, and so on. So this is how we find the x when epsilon equals 0.1. You can use a sequence diagram to find the corresponding x when the epsilon change. That is the end of the recording.